Hello, students. Welcome. Today, we're going to explore a really fascinating topic, light. We're going to look at exactly how mirrors create the images we see every single day.
So, have you ever wondered about that? Why does your reflection look just like you, but kinda swapped? To get to the bottom of this, we first need to understand the absolute basics of how light behaves.
Okay, so let's start with the very first idea. Light, for our purposes, travels in straight lines. And to show this, we draw these lines and call them rays of light. Simple enough, right? Now, when these rays of light hit a really polished surface, like a mirror, they don't just stop. They bounce back. And this bouncing back of light, well, that's what we call reflection. Smooth, shiny surfaces like mirrors are just excellent at doing this. To really understand what's happening, we need to know a few key terms. So let's build a diagram together, step by step. It'll make everything perfectly clear.
First up, we have what we call the incident ray. This is just the ray of light that is falling on the mirror's surface. See the arrow? It's pointing towards the mirror.
And after that ray hits the mirror, it bounces off, right? This ray that's going away from the mirror, we call that one the reflected ray. Okay, now for a very important part. To understand the rules of reflection, we draw an imaginary line. This line is drawn exactly at 90 degrees to the mirror, right at the point where the light hits. We call this imaginary line the normal. Now, this is a very crucial point, so listen carefully. We always measure our angles from this normal line, not from the surface of the mirror. So the angle between the incoming incident ray and the normal is called the angle of incidence. We just call it angle I. And you guessed it, the angle between the outgoing reflected ray and that same normal line, that's our angle of reflection, or angle R.
So, now that we know all the terms, let's look at the two very simple laws that reflection always follows. These are the rules of the game, and they are absolutely fundamental.
The first law is beautifully simple. The angle of incidence is always equal to the angle of reflection. Basically, the angle at which light hits the mirror is the exact same angle at which it leaves. It's a perfect, symmetrical bounce every time.
And we can write this very simply, as you see here. Angle I is equal to angle R. Please remember, this little equation, it's the key.
The second law is just as straightforward. It just means that the incoming ray, the normal, and the outgoing reflected ray, they all lie flat on the same two-dimensional surface. You can imagine drawing all three of them on a single sheet of paper. They'll never pop off the page.
So, how do these two simple laws come together to form that clear image you see of yourself in a plane mirror? Let's put these rules into practice and find out.
Now think about this for a second. The light rays that are reflecting off the mirror and coming into your eyes are actually moving apart from each other. They're diverging. So how on earth can our brain take these spreading out rays and see a single clear image?
Well, here's the magic trick. Our brain doesn't know that the light has bounced. It assumes that light always travels in a straight line. So what your brain does is it traces these rays backwards in a straight line, see the dotted lines in the diagram, until they all seem to meet at one point behind the mirror.
And this is exactly why we call the image in a plane mirror a virtual image. The light rays don't actually meet back there. They only appear to meet. It's an illusion created by our brain. You can't, for example, put a piece of paper behind the mirror and see the image on it because it's not really there.
All right. Now that we understand how this virtual image is formed, let's look at its specific properties. What are the clear characteristics of the image that you see? Okay, an image in a plane mirror has four very distinct properties that you must remember for your exams. First, it's virtual and erect. Erect just means it's upright, not upside down. Second, it's the same size as the object. Third, it's as far behind the mirror as the object is in front. And finally, number 4, it is laterally inverted. And this last property, lateral inversion, is the most interesting one. It simply means that left and right are swapped. So when you stand in front of a mirror and raise your right hand, your reflection appears to raise its left hand. This property actually has a very important, life-saving use in the real world. Think about it. When a driver looks in their rearview mirror, they will see the reversed word ambulance correctly. Because of lateral inversion, they can read it instantly and know to move out of the way. Pretty clever, isn't it?
Okay, to finish up, let's do a very quick recap of all the key points from our lesson today. This next slide is basically a perfect summary for your exam revision.
Now have a good look at this table. It neatly summarizes everything you need to know about plane mirrors for your conceptual questions. On one side, you have the 2 laws of reflection, and on the other, the 4 key properties of the image. This is exactly what you need to remember.
So, today we've mastered what happens when light bounces. But what happens when light actually passes through a different material, like from the air into a glass of water? Well, that's when light bends, and that phenomenon is called refraction. And we will explore that in our very next explainer. Thank you for joining me.